Greetings. Thank you for joining our webinar today. I would like to introduce you to our speakers, Thomas Kaiser, SAP Senior Vice President, Internet of Things, and LeverX's Sergey Seleznev, North American Technical and Development Manager. Our topic of discussion today will be SAP Leonardo and a practical demonstration of IoT. Thomas will provide the latest news around SAP Leonardo, SAP's digital innovation system. Sergey will provide an introduction to the SAP Cloud Platform and IoT, followed by a live demonstration of MisterX, LeverX's IoT simulation project, and a look into live analytics dashboards developed by LeverX. We will also provide a brief overview of LeverX's IoT QuickStart program, our two-day workshop that helps you get started with SAP Leonardo, the SAP Cloud Platform, and Internet of Things. Please, if you have any questions, put them into the chat session and we will review those. We will read and answer those questions at the end of the webinar. Everybody is on mute. So with that, I would like to hand over the presentation to Thomas for the first part of our webinar.
Good evening, ladies and gentlemen. This is Thomas Kaiser speaking from SAP, and I'm going to give you a quick overview about SAP Leonardo and our offering with SAP Leonardo on IoT. Many questions which we get from customers is what is SAP Leonardo about? And those customers, they really struggle to become a digital company. The reality is that many companies don't know what steps to take to become a digital, where to begin the journey to digital, and how to be sure that they won't waste money and on innovation which they can't implement at scale. Objective is, of course, not technologies, but to drive better business results. There are so many individual technologies outside there and buzzwords which confuses the companies. Machine learning, real-time analytics, security, natural language processing, big data, and so forth and so on. SAP sees here a massive opportunity to help customers to structure, take, and complete the digital journey. This is why SAP introduced with Leonardo the Digital Innovation System. So with the Digital Innovation System, SAP delivers many brand new and latest technologies like machine learning, blockchain, data intelligence, big data, Internet of Things, and so on. And at Leonardo, it's not only about technology. In fact, it's about business. It's about business results, business outcomes, and business processes. And the real power comes when these technologies all work seamlessly together and solve business problems. And this is the real power of SAP Leonardo, the seamless work together of all those new technologies. Leonardo for IoT, that's something which we deliver as a comprehensive end-to-end platform with a really rich set of ready-to-run IoT applications, such as connected products, connected assets, connected fleet, infrastructure, and so forth and so on. Those apps are software as a service apps which can be configured to the needs of the customers. Those applications are built on top of a rich set of the Leonardo Foundation, which is a technical set of the SAP Leonardo H. This H processing piece of software which sits on the real things in the real world, where you can do already first data streaming, where you can persist the data, where you can do first predictives already, and where you can filter the data which you want to send to the cloud. In addition, there are technical services for the device management. You can handle all your devices, you can manage the connectivity, and you handle also the messaging. On top of that, we have data management capabilities, because IoT it's about big data and handling big data, and we have intelligent storage capabilities so that we store data in different databases and with different technologies in order to enable a performant and fast access. So we have an aggregate store, we have the time series store, and we have the data archive, a cheap store for long data storage. And last but not least, we have the business services. And with the business services, you can model in a very flexible way your digital twin. So the virtual twin of the things in the real world. And based on this digital twin, you can build your very specific application based on reusable controls, reusable APIs, and based on a full stack web IDE application development. And this is in fact what Sergey is going to show in the next minutes. He shows us how LeverX did use the SAP Leonardo Foundation for IoT in order to build a specific LeverX specific application. So hand over to you again, Sergey.
Hello, this is Sergey. Good morning, good evening. Let me start with the technical architecture. On this slide, you can see key IoT components. We start from the very left side where you have devices. Then we have edge components. Edge components serve as a mediator between the IoT devices and the IoT services. In general, they are optional, but they come very handy when you need to transform or filter data at the edge. For example, if you have a device that doesn't support SSL encryption, which is mandatory to talk to SAP IoT services, then you can use IoT Gateway Edge to handle this situation. The IoT Gateway Edge supports such protocols as HTTP, MQTT, file, SNMP, serial communications, and some more. Another good example is when you have a device that generates a lot of data and you want to filter the data at the edge, then the dynamic edge processing components comes into play, and it can help you to cleanse, filter, and aggregate data. Also set conditional alerts and so on. You can also push data extraction rules from the clouds. We can have here rule engine to the edge, so the rules are essentially maintained. Next component is IoT services. It provides lifecycle management of IoT devices, which provides creation of sensors and their parameters, association with devices, onboarding, and decommissioning. Then we have such supporting components as data ingestion pipeline and streaming processes. So data ingestion pipeline is used for communication with data processing services and integration tools we have on this side. Big data services are used for data storage, obviously, where we have hot, warm, and cold types of storages. And on the right side here, we also have a machine learning component for data analysis and prediction. Next to the right, we have IoT application enablement. It's one of the key new components of IoT 4.0. Which provides a set of microservices and applications that help to manage and consume data generated by IoT services. Well, essentially, it's a layer on top of the IoT services. You don't see that as a layer, but it consumes data from IoT services, essentially. And it provides a very comprehensive tool set for device modeling, or as we call it, building digital twins. That represent real-world physical things in a digital format, and also allows you to set business partners and authorizations and run data analysis. Application enablement comes with pre-built UI templates. You can see here IoT application templates and application builder, and provides a plug-and-play user interface for rapid development of your applications and dashboards for end users. In fact, the demo scenario that I will show today, I built the UI in I spent probably 15 minutes for that without any code defined, any lines of code. And with SAP Cloud integration, which we have in here, you can exchange data with your backend system. We have two different colors on this slide that highlight different demo scenarios that we're planning to show you today. We have this blue color here, and we have green. And for the blue scenario, we will use MisterX connected to IoT services. And here, so we have device IoT services here, data ingestion, obviously data storage, application enablement, and pure application built in the IoT application builder. And for the green scenario, most of the data flows will remain the same. The only difference is that the custom developed Pure dashboard and workflow will be used in our backend system, and we will use for that SAP Cloud integration and a backend system which sits in our data center in Michigan. And we will be using IPS workflow and the Pure dashboard to run that scenario, and the IoT service, obviously. So let's move to the demonstration. First of all, let's talk who is MisterX. MisterX is an IoT prototyping platform for SAP applications developed by LeverX. It consists of hardware and software building blocks that can be used with SAP Cloud, SAP Business Suite, and S/4HANA for rapid prototyping and educational purposes. As you can see on the slide, we have 3 devices so far in MisterX family. The original MisterX on the left, LeverX IoT button that can be connected to SAP and perform any actions upon clicking the button, and IoT-enabled mechanical arm. This is the original MisterX. This is how it looks. I'll also show you live in a little bit. I'll turn on my camera. The core of MisterX and 2 other devices is a microcontroller ESP8266. It's a Wi-Fi-enabled board, which means you can connect it to SAP Cloud and your backend system with minimal infrastructure in place. It also has a number of sensors. In this example, we have a moisture sensor, temperature sensor, moisture sensor here, temperature sensor is here, light sensor, and some other sensors. There are more than 100 of other sensors and actuators that you can be connected to this platform. And here you can see some of the examples, such sensors as gas and sound analysis, weight measurement, electric current measurement, security devices, biometric devices, many other devices. The second device is that we'll be using in this demonstration, the mechanical arm. This is the picture of that. And it has the same microcontroller, but only one sensor. It's a magnetic sensor on the left side to detect a placement of a part on one of the tables on the front side of the device. I'll show it to you. And another key difference is that it has a motor driver board and 3 motors. Okay. So this a simplified data flow for the first scenario. It will be completely within SAP Cloud, besides the MisterX. Obviously, MisterX will be sitting on my desk here in Michigan. It will be using IoT Edge Gateway because MisterX can't talk SSL at this point, so we had to use IoT Edge Gateway to handle that issue, that limitation on the device side. And it's running on my laptop that I'm running this presentation from. You can also install on Raspberry Pi or any other device. Essentially, it has to be in close proximity to the physical device and located on premise. So on the cloud side, we'll be using IoT services, application enablement, and Fiori application built with application enablement UI builder. So let's open. Now we're going to switch a little bit around. I will start with the IoT service cockpit. I'm logged in SAP Cloud. It's again IoT cockpit, and here we essentially define device capabilities and sensors parameters. We start with the capabilities, and for MisterX we have MisterX CPB, which stands for capabilities. And on the capabilities, you can see different properties, so sensor properties. In our case, we have 3 properties here. Essentially, these are parameters that we're going to receive from the device. We have light, moisture, and temperature here. Then you define sensor type. And for MisterX, we have MisterX sensor type here. And the sensor type is linked to the capability type, essentially. So they link to each other. So once it's done, you can create a device, and the device for MisterX, we have device MisterX device 03, and in here you can see that we have a device name, the status of the device. It tells us that this device is running via a gateway, and it gives you your gateway ID. Every gateway instance has a unique ID. And this is the status of the system, the connection. So you can see that this device is linked to this sensor type that we defined before, right? And also, you can run a data visualization. Essentially, it provides you ability to look at key KPIs associated with this device. So we have a lot of devices. You can look, for example, how many records you have, how many data you received, and so on. You just pick sensor type here, capabilities and properties. Okay, so once the device is configured on the IoT side, and I missed one thing though, the gateways. I want to show here the gateways. This is the list of active gateways, and this is the gateway that I'm running. So this is gateway number 62. And there are 4 others gateways. And as I mentioned before, the gateway can support a lot of different protocols. In this case, we use HTTP REST protocol to run this demo, and it shows you the active device connected to that gateway. So next step is to go to the application enablement. I have it open again. It's same as SAP Cloud, just different application in the SAP Cloud. It has master data here. I won't go over that because for the sake of time, I will focus more on the Think modeler. So in application enablement, you model your device by creating a Think type, and then you connect that into your device previously created the IoT services, right? So in my case, let me go to my package, and I have MisterX package. I have this Think type, which is MisterX_type. And you can see the measured values, and they link via the MisterX capabilities, which came from the IoT. So application enablement knows whatever you created in the IoT services, so it pulls that data, and you can link it. You can link it to IoT, to application enablement layer, essentially. And then for this Thing type, I also have a thing. You see that there is one thing. And this is a MisterX thing. This is an individual device that sits on my desk and sends data. And you can see that this Thing type is MisterX type. There is an authorization group to control access to the information in this device. And also there are measured values. So these are real-time data that comes from this device. And you can see here last published numbers. Okay, and then also in here you can connect and disconnect from the device. So in my case, it's connected, and when you connect it to the connection, essentially it means that you connect application enablement layer to the IoT services layer. Okay, so next step, once you're done IoT configuration, then application enablement configuration, and once you're done with the your digital twin, then you go to and build dashboards to consume that data. So that's the Web IDE, again, running from the same SAP Cloud, right? And I won't start building from scratch. I'll just show you how it looks like. Essentially, SAP provides a number of really good templates and also freestyle templates where you can do a lot of modifications. And as you can see, unlike regular IDE and SAP Cloud, for this specific, you have IoT components, and you can just drag and drop them on the chart, on the canvas here. And the good thing about that you don't have to build data models because they're already linked to application enablement, and you can easily consume data from your application. This is how the final application looks like. You can see that's my thing. It refreshes automatically. This is the light information, the current information. You can see historical data here, and you can pick the devices that they're actually selected already here, that we connected and configured. Okay, so beside that, we also have a dashboard that consumes data from IoT services in the cloud, but this dashboard is located on premise, again, in our data center in Michigan. And you can see our MisterX here. This is the current readings from MisterX. You can see the map and location of MisterX and status. You can see a list of full devices here in this list. You can see also workflows associated with MisterX and tickets created in this system. And also you can pick a specific sensor for that specific device and see the historical data for that. So that's with the first one. And second scenario where we have RoboArm, everything is the same as I mentioned. The only difference is that we're going to consume the data from a premise, and we're going to use IPS workflow and a dashboard, and that's hosted now SAP SCC system, and data comes from SAP Cloud, from IoT services and application enablement, and we're using Cloud Connector to get that data. So let me share my camera. Now you should see the arm. On the upper right corner, you can see the status of the arm. That camera shows the LED display that is built into the arm. It's in status ready right now. And in order to activate the arm, I need to place this small vehicle here on the left side. It has a magnet inside, and there is a magnetic sensor built into the arm. So what's not just happened, it attempted to leave the vehicle, the motor got overloaded, it released the vehicle back, and it created a ticket in the backend system through IoT cloud services. And on the display now we can see ticket number 154. And now I'm going to switch back to the desktop and show you the ticket. I'm in our backend system. Let me find ticket 154. Okay, what we can see here. General summary tells us that ticket was generated by LeverX ARM on November 8th because the motor was overloaded. I'm responsible person. Down below we can see workflow. It has a number of phases and steps. Step number 1 is review ticket. It is status ready. It means I can process it. I'm going to go to the edit mode. There is a section for decisions. I'll select task completed. Next step is to hit button save. But before I click button save, I would like to switch back to one of the cameras because once I hit save, everything is going to happen very quick. So I would like you to see the moment when it starts. Now you should see the device, and I'm hitting button save. Pay attention to the display at the upper right corner. It will go to status fixed. Now watch the arm. It grabs the vehicle. It moves to the right side. When the task is finished, the arm goes to the initial position and it's in status ready. Okay, so that's the conclusion of this scenario. And the last thing that I wanted to mention, let me turn on the camera and go back to my presentation. So SAP, not SAP, LeverX and SAP LeverX runs an IoT QuickStart program. It's a 2-day program involving business leaders and technical teams within your organization, aimed at providing insight into how to enter the market of Internet of Things. There are 2 days, right? The first day is discussion of the business opportunities and market growth potential, centered around introducing or expanding the issue of IoT for your business. And the second day is discussion of the mechatronics and data platform aspects of the IT. And using the knowledge gained from these workshops, regroup with the business and technical teams to formulate a pilot product or process that could serve as a pilot IoT project. And then if we after 2 days, the third phase, let's call it a prototype, which is essentially a formal project defined via the QuickStart program and intended to build a working prototype of an IoT concept. The goal is to demonstrate a real-world application of IoT in the client's production or process phase. So that's what I wanted to present. I don't have anything else. Dave, you can take it over. Thank you.
I would like to thank Thomas and Sergey for the excellent presentation today. We will be sending a link to the presentation out to all attendees and all those who registered. Again, thank you very much today, and have a good rest of the day.